Hello, calculus type people. Hope you're having a fantastic day. Today we're going to be talking about more separation of variables. This is going to be dealing with a lot of the natural log stuff and using natural logs and e's, as I think we need a little bit more practice with that. But just a reminder, separation of variables only works if you're using multiplication or division. A reminder for you there again. So number one's a very basic example here. dy dx equals negative 3/4 square root of x. And f of 0 equals 10. Find f of x. So this part's pretty simple, pretty straightforward. Get your dx over here. That's your separation of variable step. Negative 3/4. Let's go ahead and call that x to the 1/2 because that's just going to make life easy. Dx. And then let's integrate it. The integral of dy is y. And the integral of negative 3/4 x to the 1/2, negative 3/4 x to the 3/2. And this is, I should have left a little space, so I'm going to erase just that first portion, negative 3/2 fourths, excuse me. And this is x to the 3/2 over 3/2. So let's go ahead and flip that and say it's 2/3. And plus c. Again, that came from x to the 3/2 over 3/2, but flip the 3/2 and make it your 2/3. I just skipped that step there. Threes will go away. This is negative 1/2 x to the 3/2 plus c. And this should be written more as an exponent. I apologize. Okay, so there's the general example, right? And then we can plug in our values, figure out what c is, and go about our merry business. If f is 0, or excuse me, if x is 0, you plug in a 0 here, this is all 0. That's going to leave you with c equals 10 for y, so this is just 10. Making life easy. Oh yeah, one calculus question at a time. I almost said pre-calc. Ah gosh, blasphemy. All right, so when we get into some of these other ones here, they are going to be involving the natural log, fair warning, but we know how to handle this, so it's okay. Example 2. Solve the differential equation. Now this one is given to us in a little bit of a different wording, but it still means the same thing. Natural log of y times y prime. Y prime is dy dx, right? That's what y prime is. It's dy dx equals yx. So, long story short, you have natural log of y, dy dx equals y over x. So when you get your things set up, let me do this one step at a time here. First thing I'm going to need to do is get everything that has a y over yonder. So I'm going to need to divide this side by y. I'll have the natural log of y over y from over here. Dy dx equals 1 over x. Okay, 1 over x. So all I did was multiply or divide y over here. Then multiply dx over here. You get the natural log of y over y. Dy is equal to 1 over x dx. And we have the natural log of y over y. I'm going to have to use a u substitution here because I've got a function inside of a function. So I'm going to need to call u the natural log of y. So du is the derivative of the natural log is 1 over y. Dy. 1 over y dy. 1 over y dy. So what this is actually end up looking like here, and it may make a little bit more sense to see it like this, we've got the natural log of y times 1 over y. So u is the natural log of y, and du is 1 over y dy. So what I end up with then, fancy enough, is u du is equal to 1 over x dx. Who'd have thunk it? So integrate both, and you end up with u squared over 2. The integral of the 1 over x, the integral of 1 over x is the natural log of x plus c. And then plug your u back in. I'll bring that up here before I do that. Plug u back in, and you get the natural log of y squared over 2. Natural log of y squared over 2 is going to be equal to the natural log, I'm sorry, I forgot my absolute values. How dumb of me. Of the absolute value of x plus c. And then finally use our initial condition here. Everywhere I have an x is 1, and everywhere I have a y, it's e. So I have the natural log of e squared over 2 equals the natural log of the absolute value of 1 plus c. The natural log of e is 1, so 1 squared is 1, so you have 1/2. The natural log of 1 is 0, so that's just c equals 1/2. So that leaves us with, and I'm just going to leave it actually in this format right here, the natural log of y squared over 2, natural log absolute value x plus 1/2. And I'm going to leave it like that. I can leave it like that because it just says solve the differential equation, but it doesn't say that it wants me to find f of x, or it doesn't want me to find y. It just wants me to solve it. Figure out what the equation is. Fantastic. I'm done. I've got my differential equation, and I'm ready to move on. Example 3, another way of asking a different question. At each point on xy, on a certain curve, the slope of the curve is 3/4 y. If a curve contains a point 0, 10, find its equation. So again, they've told me the slope of the curve, and if it sounds like I'm getting farther away, it's because I need to sharpen my pencil. We always say sharp pencils for sharp minds. Now I've got 2. Okay. The slope of the curve is 3/4 y. Well, what they just told me, dy dx is 3/4 y. Bam. That's what the slope of the curve is. So I've got, let's see, I need to move my dx over here, move my y over here. So divide by y, you get 1 over y dy is equal to 3/4 dx. Now, I like to write it like this, 1 over y dy, because I always know when I integrate 1 over y, I'm going to get a natural log. Absolute value of y is equal to, the integral of 3/4 is 3/4 x plus c. Now the way that I'm going to show you to do this, there is another way that you could do this. The first method is plugging in a 0 for x, plugging in a 10 for y, and trying to solve for c. That does end up being simple, I guess, but to me it's not quite as easy as what I'm about to show you, because what I'm about to show you involves calculus magic. Okay, so what I'm going to do first, to figure out what c is, I'm going to solve for y, and I'm going to get everything else just as y. So let me bring this up here. I'm going to rewrite this equation. Natural log of y is equal to 3/4 x plus c. And what I'm going to do is e both sides. I'm going to solve for y is equal to e to the power of 3 over 4x plus c. Now you may be saying, Mr. Ballard, that doesn't look any type of easy. We've got e to this giant, big, confusing bleh. Calculus magic. You know that when you add exponents like this, I could also split them up and call this 3/4 x e to the c. See, if I add their exponents like that, I can split them up and use them as multiplying two bases. That's a little bit of pre-cal. That's your laws of exponents from pre-cal and Algebra 1. Now, what's cool about this? Calculus magic. E to the c is just c. E is a number. C is some arbitrary constant. I don't know what it is. But no matter what C is, it's going to change E, right? So this will no longer be E. That makes this just some arbitrary number. This is a number to a number, which really just makes it a number. So what that means is that C times e to the 3/4 x is the same thing as e to the c. Calculus magic, man. Now plug in a 0 for x. E to the 0 is 1. C is 10. So let me plug that in so you can see where I'm getting that from. C e to the 3 over 4 times 0. This is all 1. C equals 10. And what's cool about this is I've already got y solved for right here. Y is equal to e 3 over 4x plus 10. Calculus magic, man. Oh, wait, no, I'm sorry. Down here. Almost jacked that one up. Whew, here's my y. That's the one I want. 10 e to the 3/4 x. I got so distracted by the magic that was happening on my paper that I didn't even pay attention to what I was doing. This is the c I solved for, so it's 10. If I was to use this c up here, it would make it a different c, and it would throw my equation off. But by bringing it down and just calling it some other c, I got to make sure I put it back into that equation where I got c from. As some like to say, getting sassy with the calculus. Moving on. Example 4. Good stuff here. Find a general solution for the differential equation dy over dx equals y minus 2 sine x. Oh, yeah. First, y minus 2, I'm going to leave them together. Why not? Let's move these guys over here. Move dx over. Excuse me. I'll have 1 over y minus 2 dy is equal to sine x dx. Yay! Now, this is a u substitution. I've got a problem down here. This is like saying y minus 2 to the negative 1. That's a big issue. So, can't do that. So, I'm going to call u y minus 2. So, du is the derivative of this, which is just dy. It's 1 dy. So, fantastic. This is going to be the integral of 1 over u du, the integral of sine x dx. Yay! Integral of 1 over u is the natural log of u. Integral of sine x is negative cosine x plus c. Yay! And then we plug our u value back in. Let me bring this up over here when I do this. This is the natural log, and again, I forgot my absolute values. What is my deal today? Natural log, absolute value, y minus 2. equals negative cosine x plus c. And I'm going to use that same calculus magic, and I'm going to e both sides. Y minus 2 equals e to the negative cosine x. And this is kind of like saying e to the c again. So I'll just do it real quick so you can see it, plus c. So we've got y minus 2 is equal to, remember this is the same thing as saying e to the negative cosine x, e to the c. You can split those up with properties of exponents. And we said this guy was just c, so it's going to be c e negative cosine x. Excuse me. And then add the 2 over. Y equals c e to the negative cosine x plus 2. And we don't have to solve for what c is yet because we don't have it yet. But we do down here. Find a particular solution if f of pi over 2 is 8. So 8 equals c e to the negative cosine pi over 2 plus 2. This is c, e, and cosine of pi over 2 is 0. Right? Subtract your 2, you get 6 is equal to c. This is all 1. 6 is equal to c. So f of x, or y, whatever you want to find here, 6e to the negative cosine x plus 2. Takes a little bit of getting used to with this calculus magic here. A little notation for you here, a little note. In example 3 and 4, there's a pattern here. dy dx equals ky. There's some value times y. You end up with a solution that's c e to the kt. That comes a little later, but keep it in mind for right now. It's nice to notice if you noticed. And example 5, last one. E to the y dy dx equals 2x. Y of 1 equals 2. Find a particular solution. So this one's pretty simple. Get your dx over here. E to the y dy equals 2x dx. Good enough. Integrate both sides. Ah, fancy, fancy. The integral of e to the y is just e to the y. Integral of 2x is 2x squared over 2, which is x squared, plus c. Initial condition. 1 for x, 2 for y. E squared equals 1 plus c. So c is e squared minus 1. Fun. That means that your equation e to the y from right here is equal to x squared plus e squared minus 1. That's your c. Now, of course, I can't leave it like that. I need y. All these are in y equals, so I need y. So I'll natural log both sides. And I'll get y is equal to the natural log of x squared plus e squared minus 1. B. Yahtzee! Fun times!